Welcome. It's my pleasure to be talking in front of you. It's what I do normally as a professor at Arizona State University is speak to students and that. But today I'm going to very briefly give you a background of a trenchless technology, which is my favorite technology, and I think it's one of the most versatile trenchless technologies, and that's horizontal directional drilling. And to give you a bit of a background, it's a technology that can make installations lengths of over 3,000 meters. The longest ever was 5.2 kilometers in Hong Kong. So we're doing longer and longer installations of underground utilities. So this is a new installation method. Diameters as small as 50 millimeters and up to 1.65 meters is the largest installation ever. But typically we're doing installations in the 300 to 600 millimeter range or a little bit larger. Those are the types of installations that we do. And we can install many things, including utility conduits and fiber optic networks or gas lines, distribution, electrical lines. You know, when we have storms, it's better to have the electrical lines buried than above ground, or if there's snow or ice events, things like that. So we install those underground, and oil and gas pipelines. We do a lot of those installations because we're going underneath water bodies or rivers and places that you can't get access to. So they're very, very advantageous to use those. Municipal pipelines, even in the water and sewer, we're using horizontal directional drilling to install a water main or a sewer force main, and in some cases gravity sewers, but we have to make sure that we don't have too flat of a grade for gravity sewers. Horizontal remediation wells to clean out contaminated sites, and sometimes for geotechnical investigations. Some of the books that are out there that we look at are from the American Society of Civil Engineers. The Pipeline Design for Installation by Horizontal Directional Drilling is a manual of practice that is quite well recognized. And then this book here, the NASTT, the North American Society for Trenchless Technology, has a book called The Horizontal Directional Drilling Good Practices Guidelines, and I'm actually one of the co-authors of this book, and this book is available in English, French, Portuguese, and Mandarin. So it has quite a lot of applications, but it gives you a good indication of trenchless horizontal directional drilling. In horizontal directional drilling, we use drilling fluids like we do in other types of trenchless new installations, but drilling fluids play a really important role in HDD. And these drilling fluids come in these 50-pound packages, and it's a type of bentonite. It's a special type of clay that we mix with water that helps us actually do the directional drilling process. And HDD is a two-stage process. So this is the first stage is what we call the pilot bore. And what we do is we use a drill bit, and we will drill an arc underground, and we can track where we're going and come out at the target end. And that's the initial borehole that we are designed to have our utility installed in. And what's very important is we understand now, hopefully, is that geotechnical conditions are really critical. And so we need to know what kind of soils or rock that we might be encountering. And so that helps us select the actual tool to cut through. So these are soft bits. And so when you're in sands or soft type clays, we would use a drill bit such as this. You're not going to use this in rock. So what we say are anticipated conditions. We do the geotechnical evaluations, and then we say, I think we're going to be in sands, and so let's try using these bits if it were because of the sand. If we get into little harder soils, like maybe some hard clays or stiff clays, then we would use these types of bits. And you can see they have a teeth on them and things to kind of at least cut better through the surface underground. And if we have rock, then we use bits that can cut through rock. And the thing is we have to know that the rock is there. If we don't know, then if we use the wrong tool, then we're not going to be able to make that pilot bore. So we have to be very careful with that. In terms of most of the directional drilling, so about 90% of directional drilling uses what's called a walkover system, and that locates the head. So as you're drilling, you know where that head is, and you know what depth it is. You know what pitch, so that's the elevation. Is it flat? Is it 0 degrees? Is it positive, going up, negative? And you know, and the third thing is what we call the clock face position. And if you look at the drill bit here, it's slanted. And so when it's slanted downwards, the clock is 6 o'clock. If it's slanted upwards, it's 12 o'clock and anywhere in between. And so why that's important is if this person up top is recording the information as they're going and they stop and they say, oh, we're a little bit to the right. So they tells the operator to turn the drill bit to 9 o'clock position. So now it's facing 9 o'clock and just push the rod. And so as you push it, because there's a deviation or a slant, it'll push in that left direction. Likewise, if you're a little low, you go to 12 o'clock and you push it and it'll push upwards. And so that's what it is. This is an electromagnetic system. And right here is a transmitter, has 2 C batteries that you'd put in, and it emits an electromagnetic signal to the surface that's captured by this box here. And that's 90% of the drilling. We do have methods for crossing rivers or water bodies where we use a wire line, but I think we'll get to that in this. So there's another type of technique, the same system, just a different company. And you know, like I said, it collects that information. What's really interesting, and one of the innovations in the last 10 to 15 years, is this remote. And so what the operator, the person in the field has there, the person on the rig can also see the exact same monitor wirelessly, so they have an idea of what's happening during that locating. And that's the D, or the directional, in horizontal directional drilling, and it makes it very nice in that way. So once you've had that pilot bore, now you have to enlarge the hole so you can install whatever pipe, you know, whether it's a telecom line or a gas line or electrical line, you need to install that conduit. And so what we do is we have what's called a reamer, and what that does is it enlarges the hole. And then we have a swivel because it's rotating and cutting the hole, and we have some pipe that we don't want moving around as we're installing it. So when we pull back, so now we're pulling back towards the rig, and we rotate this, and this reamer is, in a rule of thumb, is 1.5 times the outside diameter of the pipe. So if you have a 300 millimeter pipe, you're going to have a 450 millimeter reamer. So it helps you to facilitate the installation. Our drilling fluid is through the middle of the rods, comes through, and it comes out the end of this so that it helps to cut the soil and remove the soil that you're cutting. Just like with drill bits, this reamer, we have to match to the anticipated geotechnical soil conditions. And so in this case, it's if you have sands or soft conditions, you'll use some sort of reamer like this, because these reamers, they actually mix the sand. And so as they're mixing the sand, they're removing particles. Whereas if you're in clay, you want to chop the clay to kind of cut it up. And so you would use reamers such as that for clay. So it's very, very important in any trenchless to understand the geotechnical conditions that you learned in the last module. We protect the pipe as we're pulling it in, so we have to join the pipe. We either fuse the pipe together or we weld the pipe if it's steel pipe. So fuse if it's plastic, weld, or use some other joining mechanisms that we can actually tow or pull the pipe through that hole. But we protect the pipe because for 2 reasons. One, we don't want it along the ground because it could get damaged. It could hit a rock and maybe the coating will get damaged. Or 2, we don't want to play a tug-of-war game, because if it's on the ground, there'll be frictional forces that are opposite to the direction you're trying to pull into. And so now you have to overcome those as well. You want to minimize the pulling forces that you have. It's also very common practice to have what we call multi-duct. And so here you can see they're pulling in many ducts, casings, pipes at the same time, and inside of those is what will go the product. So a lot of these are things for electrical or for telecommunications. We'll pull these plastic ducts, and then we'll put inside each one of those a different type of telecom line for fiber optics or electrical ducts and that in those particular lines. This is a setup. You can see when you're driving to the job site, you have your rig, you have your systems to mix your drilling fluids and all of these equipment that are attached to the job. And just to now finish up showing you some pictures of rigs. This is what we call a small rig. So it's a type of rig that you'll see in an urban setting. Going to install not a very long distance, but will install some sort of a telecom cable or a smaller type of utility. This one is, these are less than 300 millimeters typically, but that doesn't mean you can't go larger, but that's typically what we would do. Here's a much larger setup. This is a big rig setup, and you can see we use HDD in the winter, so it's great for climates that are cold climates as well. So this one is in Canada, I believe, that this project is, and you can see it's a very large rig. They're going to do a very long distance, several kilometers in this particular project. A couple of interesting ones. This one is a very nice project in the Washington, D.C., the capital of the United States. And that's where all the museums are. And it's a very famous, the monument, the Washington Monument there. And they were putting in water lines. They were replacing water mains, potable water drinking lines. And HDD was how they did it because they couldn't dig up the land and disrupt the tourists that are coming to do that. So I took this picture on this particular project. There you can see the drill operator sitting on the machine during the installations. This is a very interesting sea outfall project in the south of France. And they actually drill into the ocean a set distance out here, and they come up a little bit, and then they can actually release some effluent water there. So it's nothing that is toxic, but they have excess of it. So they would do that. So that's what this directional drill is for. Cold drilling, we drill in situations that are minus 40, minus 30 degrees. We can drill or even colder when we do that. And so the equipment can handle that type of environment, as you can see here, right? And so it in warm temperatures, cold temperatures, it works very, very nicely. This is the largest HDD machine in the world. That's in, I think it's like 200-ton machine. It's in China. Was manufactured recently. There's only one of its kind in the whole world, and it was just manufactured within the last 2 years and used on some projects. But it is an incredible showing how manufacturers are increasing the usage of this, or the tonnage of these types of machines. So to conclude, horizontal directional drilling equipment can be installed a wide range of utilities, and that's what makes it very versatile. So we're not just installing sewer or not just installing water, but we can do many utilities. And the big applications worldwide right now are telecommunications. We're making fiber optic cables, 5G, for the cell phones and for the communication networks. We're also doing a lot of electrical lines where we're taking above ground electrical lines and burying them underground with trenchless because of winter weather or hurricanes or earthquakes or any kinds of these situations where lines on poles can fall down. There's a number of available pipe that can be used in the installation process. So you can use steel pipe or PVC pipe or high density polyethylene pipe or ductile iron pipe. We have options of pipe that can be used to install with HDD. And it's a minimally intrusive trenchless method and very suitable for highly congested areas. And so we see a lot of HDD kind of applications in urban settings where we have a lot of utilities, a lot of people moving around, and we don't want to cut an open cut to try to do an installation because of the traffic disruption and also the potential danger of hitting another utility with a backhoe bucket and that. So with that, I will conclude my brief presentation. Thank you. And offer any questions that you might have.
Yeah, I've got one.
Yes.
If there's different materials along the drill, will they have to use one bit and then reverse out to change the bit if they hit rock?
Wonderful question. So the question was, is if we have different types of soil, we might start in sand and then we might run into rock. Absolutely. And that's one of the beauties of horizontal directional drilling, is that it has a reverse. So if we're drilling in sand and all of a sudden we hit rock, then we can reverse, come back out, change the bit out, and continue, and then go through the hole again and continue. So from a risk perspective, it minimizes that compared to, say, microtunneling or some of the other pipe jacking or some of the other trenchless methods, which you better have a very good idea of what you have, because there's no reverse. Once you start going, you have to finish. Any other questions? All right, right on schedule. Thank you very much.
Thank you.